So let's start with the first thing. What is ACI? ACI stands for Application Centric Infrastructure. This is a concept of Cisco, and this is basically Cisco's approach towards SDN. SDN is software defined network, means the network will be managed, operated and controlled using a software. So here we are talking about switches of data center. Friends, nowadays everybody is talking about virtualized environment. Most of the applications have been hosted or migrated into cloud. So cloud is nothing but a big data center where there will be powerful switches and servers. So applications will be hosted in those servers. So we have to build, design a robust data center network, and ACI will serve the purpose in that respect. You must have noticed that in the COVID-19 time, 99% of the users were accessing SaaS based applications which were hosted in cloud like Office 365. If there is any outage to any of the applications of SaaS, there will be effect to the customer experience and there will be loss of business. So you have to design very robust network. Now what is this SDN? I told you in this we will use the software to operate and control the network. That would mean that you have to decouple or extract the control plane from the device. So if there are 5 switches, you will be managing all of the 5 switches from a single place, controller or a server. For that you have to extract the control plane from the forwarding plane. Forwarding plane will remain with the device, and control plane like the brain, the CPU work, whatever work CPU used to do, that will be centralized. So in this ACI, that central server is known as APIC, Application Policy Infrastructure Controller. Okay, so the server is very important. You will be using it. So policy will be built in this controller and pushed over to all of the switches in the environment. Point number 2 says that it overcomes the complexity of Cisco's 3-tier architecture, that was core, aggregation and access layer architecture. The issue with that architecture is that it is not very consistent and troubleshooting is very difficult at times. This is 3-tier architecture. Your all SVIs will be created here. ACLs, route maps, everything will be done here. MPLS circuits or internet circuits will be connected on this core layer. Let's say you have to add 5 switches in this environment. So what will happen? You have to configure those individually, and also you have to go to other switches to set up the IP addressing, create SVI or L3 gateways, configure trunks, set up the policy, quality of service, route maps, whatever. So it takes huge time. So management is tough and troubleshooting takes time. Now we have this Cisco ACI model. Here there would be only 2 tiers, 2 layers. This is first layer and this is second layer. So the first layer, it will be known as spine layer. The devices in this tier will be known as spine switches. So I'll talk about this spine and leaf at later stage as well, but I'm just giving you high level overview. The second tier will have leaf switches. Like in this case, I have 6 switches. So each leaf is connected to each spine and each spine is connected to each leaf. And you must have noticed in this diagram that there is no interconnection between spine and other spine. Means this spine is not connected to this spine. Similarly, this leaf is not connected to this leaf. So it is pretty consistent. So even if these 3 spines go down, the connectivity will remain available. Like this leaf will be able to connect via this spine. And remember, not every switch will become spine and not every switch will become leaf. You have to refer the Cisco documentation to find out which switch is capable to be spine. And this APIC. This APIC is used to manage the complete fabric, complete set of devices. It is being displayed on the top. That doesn't mean that it is connected to these spines. It is not true. All of the servers will be connected only on the leaf switches. You cannot connect any server on the spines. Just for the presentation, I have kept this APIC on the top. So all of the policies will be set up from this and pushed over to all of the devices. Cisco recommends that there should be minimum 3 API controllers, and in the odd numbers like 3, 5 or 7. You have to build a cluster. If one epic goes down, other epic in the cluster will take over. And if all epic servers or controllers go down, no impact to the data flow because it doesn't take care of the forwarding. It doesn't sit in the forwarding plane. If all epic controllers are down, no impact to business. I repeat. So you must have noticed one more thing. If you want to add one more device in this, simply add and connect it to all spines. Right? We use two-tier architecture known as clause architecture. Charles Clause was a person who designed it. So we use spine and leaf switches. Mainly we use GUI to operate the epic controller. So either you can use GUI or CLI, but these cannot be used at the same time unless you delete the existing configuration. What I want to say is that if you are using CLI at one time, you cannot switch over to GUI without deleting the complete configuration. Preferably, we will use GUI in almost all cases. But yes, some switches are capable of CLI, but not all switches are capable of CLI. Point number 4, all connections in this ACI fabric will be from leaf to spine and spine to leaf. No connection from spine to spine or leaf to leaf. Explained. You see, there is no connection. Similarly, no connection. Point number 5. So in this ACI architecture, we will be using Nexus 9000 series devices. And there are mainly 3 sub-series, 9500, 9300 and 9200. This series is mainly used for spines. Spine is equivalent to your distribution or core layer capable device, powerful device. And 9300 mainly for leaves. Leaf can be attributed to access layer switches in data center. We don't connect a workstation to these switches. Now, Cisco ACI fabric doesn't use STP. Actually, STP we have learned from the beginning, it is used for avoiding layer 2 loops. But the issue with this is that, let's say these are 3 switches, there are 3 links. If we use STP and let's say this link is blocked, it means capability of this link is not used. So it's a wastage of resources. Okay, so STP is not very effective. It doesn't let us use the complete set of resources. We have to exploit the resources to be able to get the complete benefits. So STP is not used in ACI. So what we use? Actually, we don't use L2 in this ACI fabric. This is not a L2, okay? It's a L3 fabric. Since it is not L2, it means STP will not be used. So here we will use ECMP to achieve the load sharing equal cost multipathing, because from every point number of hops will be maximum 2. Let's say this is S1, this is S2, S1 wants to talk to S2. What is the way to reach S2? This is first way, this is second, third and 4. And number of hops will be 2 only. Like if this is the first hop, this will be second hop, and then there will be connection to this. And if the traffic goes to the second spine, number of hops will be 2 only. So here we will use ECMP, equal cost multipathing. In addition to that, we use ISIS routing protocol in this fabric, and we use VXLAN. I'll explain these two at later stage. And one more thing, we don't use CDP here, we use LLDP. And it's very easy to operate these devices. Means from the management point of view, not from the technology point of view. You have to learn many things. This one is done. Point number 7, it says in the traditional network device, if you have a interface, so if you don't have any ACL applied, it would mean everything is allowed by default. So this method is known as blacklisting, means you are permitting everything by default, which is not a good thing. ACI doesn't follow this method. It follows whitelisting. So by default, everything will be blocked unless you allow it. That's what I want to say. Point number 8, device management is super easy using APIC in ACI fabric. Centralized controller policy will be there, push it to all devices. We don't have to manually log in into every device. That's the main thing. Topology is also very consistent. This thing I have already explained you. Minimum 3 APIs need to be used, but in odd numbers like 3, 5, 7. I mean, if you want to use 5 APICs, 4 is not recommended. Even number is not recommended by Cisco. Minimum 3. And these need to be in cluster so that whatever you configure, whatever policy object you set up, that gets copied automatically to the alternate API controllers. If all fails, no impact because it doesn't sit in the forwarding plane. in Cisco APIC server, whatever we configure, that will be stored in the form of object or policies. So these objects and policies can be accessed using Cisco API. API is basically an interface. It's a kind of coding or a file. I don't know much about this API entirely, but what I want to say is that let's say that we are using GUI to access APIC. So whatever policies or objects we create or delete, ultimately those will be converted into CLIs, right? Device understands CLI. So in between this conversion of GUI to CLI, there would be API, application programmable interface. So these policies can be accessed using this API and also be modified as well. And these objects and policies are stored in XML or JSON format. That's what I wanted to tell you in this first lecture. Thank you so much.